What if the gentle hum of your own awareness, the silent movie playing behind your eyes right now, isn't just a byproduct of biology, but a direct connection to the fundamental fabric of the universe? This is a quiet corner of the cosmos, where we soften the hard edges of quantum mechanics and dress the profound enigma of consciousness in its favorite pajamas. Tonight we embark on an extraordinary exploration, a journey into the idea that your very brain might be a quantum antenna, tuned into the symphony of the universe. We'll delve into recent mind-bending experiments suggesting that deep within your neurons, structures are vibrating in ways that defy the rules of classical physics, even at the warm temperature of your body. This isn't just a philosophical fancy. It's a scientific revolution hinting that the phenomenon of quantum entanglement could be the very thread linking your individual mind to the quantum fabric of reality itself. This discovery has the potential to reshape everything we think we know about who and what we are. I truly hope this exploration doesn't keep you awake, but if it does, I think you'll agree that contemplating the quantum nature of your own consciousness is a fair trade for a few moments of lost sleep. If you enjoy these gentle dives into the deep end of science, please do tap the like button, subscribe for more voyages, or leave a comment telling me where and when you're listening from. For now, take a deep breath, settle in, and let's voyage together into the quantum nature of the mind. What if the answer to the greatest mystery of all, the nature of consciousness, isn't found in the grand firing of neural networks, but is instead hiding in the tiniest, most overlooked spaces within your brain? As you listen to these words, a delicate dance is taking place inside your neurons. Billions of microscopic hollow tubes, known as microtubules, are humming with activity. For a long time, these structures were seen as little more than cellular scaffolding, the passive support beams of the neuron. But what if they are infinitely more? What if they are the secret architects of your inner world? Groundbreaking research now suggests these microtubules are behaving in ways that classical physics says should be impossible, vibrating with quantum coherence in the warm, wet and noisy environment of the brain. This isn't science fiction. It is the dawn of the quantum consciousness revolution, a paradigm shift unfolding in laboratories around the globe. From Wellesley College, where researchers are investigating how anesthesia seems to specifically disrupt these quantum processes in microtubules to induce unconsciousness, to Trinity College Dublin, where scientists have detected the first tantalizing hints of quantum entanglement within the living human brain. The evidence is mounting. It all points toward a staggering conclusion. Your consciousness, your subjective experience of being alive, may follow principles far stranger and more profound than we ever dared to imagine. Let's trace this idea back to an age-old question, a puzzle so profound it has been dubbed the hard problem of consciousness. How does the 3-pound lump of tissue nestled inside your skull, a complex yet entirely physical object, give rise to your rich, private inner world? Think about it for a moment. It's not just about processing information. It's about the experience, the vibrant, unmistakable redness of a rose, the comforting warmth of sunlight on your skin, the bittersweet pang of a half-forgotten memory. Where do these feelings come from? This is the crux of what philosopher David Chalmers calls the hard problem. The easy problems, relatively speaking, involve understanding how the brain processes data, how it can distinguish a cat from a dog, or retrieve a memory. The hard problem is explaining why all that processing feels like something from the inside. Why isn't it all just dark, robotic computation with no one home to experience it? For decades, the dominant view in neuroscience has been that consciousness is an emergent property of classical neural patterns, like a traffic jam emerges from the interactions of individual cars. But this doesn't bridge the explanatory gap. It doesn't explain the why of subjective experience, allowing for the unnerving philosophical possibility of zombies, beings who could process information and behave identically to us, but with absolutely no inner awareness, is precisely this gap, this chasm between the physical brain and the felt reality of experience, that is driving a bold new wave of researchers to look beyond the familiar world of classical physics. They are turning their attention to the bizarre and wonderful realm of quantum mechanics, the fundamental theory that governs the universe at its smallest scales. Here, particles can exist in a superposition of multiple states at once, like a coin spinning in the air before it lands. They can become entangled, mysteriously linked across vast distances in what Einstein famously called spooky action at a distance. And they can perform feats like quantum tunneling, passing through barriers that should be impenetrable. For much of the 20th century, these quantum effects were considered far too delicate and fragile to play any meaningful role in the warm, chaotic environment of a living brain. The prevailing wisdom was that such quantum states required temperatures near absolute zero to avoid being instantly destroyed by a process called decoherence. But as we are now discovering, nature is far cleverer than we gave it credit for, and has found ingenious ways to harness and protect quantum coherence, even at room temperature, in places we never thought to look. The idea of quantum processes in the brain isn't as outlandish as it first sounds when you realize that biology has been exploiting the quantum world all along. Consider photosynthesis, the process that powers nearly all life on Earth. It uses the principle of superposition to achieve near-perfect efficiency, allowing energy from sunlight to explore all possible paths to the reaction center simultaneously to find the most efficient route. Think of birds navigating thousands of miles with pinpoint accuracy. They may be using quantum entanglement within proteins in their eyes to see the Earth's magnetic field. Even our sense of smell might rely on quantum tunneling, where electrons pop through energy barriers to help us distinguish one scent from another. Seeing these quantum tricks in action throughout the biological world makes the idea of quantum processes in the brain seem not just plausible, but perhaps even probable. This grand story brings together two remarkable minds: Sir Roger Penrose, a Nobel laureate and mathematical physicist, and Stuart Hameroff, an anesthesiologist. United by a shared conviction that classical physics alone could never account for the richness and mystery of consciousness, they embarked on a journey to find a new explanation. In the 1990s, Penrose and Hameroff unveiled a radical and elegant proposal they called the Orchestrated Objective Reduction theory, or Orch OR. Their theory posited that consciousness doesn't arise from the simple firing of neurons, but from something far more fundamental: quantum computations occurring within the microtubules inside those neurons. They suggested that these hollow protein tubes, which form the structural cytoskeleton of our cells, were not just passive scaffolds, but sophisticated quantum computers. The orchestrated part of the theory refers to how these quantum processes are organized and influenced by the brain's biological structures, while objective reduction is Penrose's proposed solution to a major puzzle in quantum mechanics: how quantum possibilities collapse into a single, definite reality. He suggested this isn't random, but an objective physical process linked to the geometry of space-time itself. Naturally, the theory was met with immense skepticism. The primary objection was decoherence. Critics argued that the brain, at a warm 37°, was simply too warm, wet, and noisy to sustain the delicate quantum states required for even a fraction of a second. Any quantum coherence, they claimed, would collapse almost instantly, long before it could influence any neural processes. For years, the skepticism seemed justified. But then, a series of stunning discoveries began to challenge the long-held assumptions. Biologists started finding evidence of protected quantum coherence in various living systems. In a landmark study, researchers at the University of Alberta observed that microtubules could indeed sustain coherent quantum states, lasting for nanoseconds. In the quantum world, a nanosecond can be an eternity, more than long enough to perform complex computations. Following this, a team at the University of Central Florida found evidence that these quantum states could endure for even longer, potentially for whole seconds, giving them ample time to influence the firing of neurons. Suddenly, the image of microtubules shifted from being passive structural supports to active dynamic quantum processors at the very heart of the brain's operations. The warm, wet, and noisy brain was not a barrier to quantum effects, but perhaps the perfect environment for orchestrating them. One of the most compelling pieces of evidence for a quantum theory of consciousness comes from an unexpected place: the operating room. Anesthesiologists like Stuart Hameroff have long known that anesthetic gases render a patient unconscious, but the precise mechanism has remained a mystery. The Orch OR theory predicted that anesthetics work by specifically binding to microtubules and dampening their quantum vibrations. In a groundbreaking 2024 experiment, a team at Wellesley College put this prediction to the test. They found that anesthetic agents do in fact induce unconsciousness by binding to microtubules and disrupting their quantum activity. Even more remarkably, when they administered a drug to rats that stabilized their microtubules, the rats resisted the effects of the anesthetic for significantly longer. This established a direct causal link. Disrupt the quantum processes in microtubules, and you disrupt consciousness. The implications are nothing short of revolutionary. If losing consciousness is directly tied to the cessation of quantum activity, it strongly implies that having consciousness requires it. If this quantum view of the mind is true, its implications stretch far beyond our individual skulls. First, it could explain how consciousness is unified. How do all the disparate sensory inputs and cognitive processes in your brain combine into a single, seamless field of awareness? Quantum entanglement could be the answer. It also suggests that our brains can process information in ways that far outpace even the most powerful supercomputers, which are based on classical computing. But perhaps the most profound implication is that our minds may not be entirely confined to our heads. Entanglement, the spooky action at a distance, could mean that our consciousness is fundamentally linked to the quantum field of reality itself. In a truly astonishing development, researchers at Trinity College Dublin, using a modified MRI technique originally designed to look for quantum gravity, detected what appeared to be signatures of entanglement between different regions of the human brain. This is one of the first hints of a macroscopic quantum effect in a living biological system. If confirmed, it would revolutionize our understanding of consciousness, suggesting it is not an isolated phenomenon, but an interconnected part of a cosmic web. Of course, the theory of quantum consciousness is not without its formidable challenges and critics. Many neuroscientists and philosophers maintain that classical neural networks are fully capable of explaining consciousness, given enough complexity. They point to the rise of advanced AI like ChatGPT, which can mimic human-like cognition and language using purely classical computational principles. They argue that while the observed quantum effects in microtubules are impressive, correlation does not equal causation. Just because we see quantum phenomena in the brain doesn't definitively prove they are the cause of our subjective experience. The gap between observing a quantum collapse and explaining the feeling of seeing the color red remains. Furthermore, the theory raises deep philosophical questions. If our choices are based on the probabilistic nature of quantum mechanics, does that give us free will, or are our actions simply random? And if our minds can be entangled, what does that mean for our sense of individual identity and selfhood? Despite the valid skepticism, there is a profound philosophical beauty in this emerging picture of consciousness. It suggests that our minds are not separate from the physical world, but are woven into the very fabric of the universe. In this view, mind and matter are not two distinct things, but rather two aspects of a single, unified reality built on quantum information. This idea echoes the wisdom of ancient spiritual traditions that have long spoken of a fundamental interconnectedness of all things. It feels like we are coming full circle using the most advanced tools of modern science. Quantum field theory, advanced neuroscience, information theory, to paint a picture of reality that is, in many ways, stranger, more wonderful, and more unified than we ever imagined. This is just the beginning of our journey. In the explorations to come, we will probe deeper into the evidence for quantum consciousness. We'll examine the specific mechanisms that might give rise to subjective experience and explore the cosmic implications of a mind connected to the universe. We'll look at the astounding world of quantum biology, from the quantum compass in a bird's eye to the flawless efficiency of photosynthesis. We will investigate the cutting-edge experiments being conducted in brains and grapple with the profound shifts in our understanding of reality that this new science demands. But for now, as you settle into a state of rest, I invite you to simply hold this sense of wonder. The possibility that your own consciousness is not just a flicker in the dark, but a vital note in a grander quantum symphony. The universe, perhaps, is dreaming through you. This revolution is not a distant theoretical concept. It is unfolding in real time. In California, researchers are now able to map the collapse of quantum coherence in the brain with stunning precision as anesthesia takes hold and awareness fades. This suggests that the very state of being conscious is a state of sustained quantum processing. Think about what this means for your everyday experience. That fleeting feeling of melancholy on a rainy day, or the simple, undeniable experience of the color red when you look at a sunset. These might be the result of countless quantum superpositions collapsing into a definite, singular feeling. Your subjective world, in this view, is built from the raw material of quantum possibility, moment by moment. One of the most famous and mind-bending tenets of quantum mechanics is that the act of observation fundamentally shapes reality. This is most clearly demonstrated in the famous double-slit experiment, where particles behave as waves when unobserved, but collapse into definite particles the moment they are measured. If consciousness itself is a quantum process, this takes on an entirely new meaning. It suggests that our awareness is not a passive spectator, but an active participant in the creation of reality. Every moment of conscious experience could be an act of creation, collapsing quantum wave functions in our own brains. In this light, the brain is evolution's ultimate quantum computer, and according to the Orch OR theory, your microtubules are performing these computations at an incredible rate, generating something like 40 distinct frames of conscious awareness every single second. The evidence continues to accumulate. Researchers in Alberta have demonstrated that microtubules can indeed maintain quantum coherence at body temperature, overcoming one of the biggest initial objections to the theory. This coherence isn't isolated. It's believed to be orchestrated across the brain via tiny channels called gap junctions, which allow for a unified quantum state to emerge. This provides a beautiful and elegant solution to what philosophers call the binding problem: how the brain takes separate sensory inputs, processed in different regions, and binds them together into a single, unified experience. The answer might be entanglement. By entangling different regions of the brain, a single, integrated field of awareness is created from countless individual quantum events. The Trinity College experiments detecting entanglement in the brain are a critical piece of this puzzle. If confirmed, it would be the first evidence of a large-scale macroscopic quantum phenomenon in biology. This flips the old model on its head. Instead of consciousness being an emergent property that arises from complex classical computation, this view suggests that consciousness is fundamental, like gravity or electromagnetism. Our individual minds would then be local expressions of a universal quantum awareness field that pervades the cosmos. This idea is reminiscent of the physicist David Bohm's concept of an implicate order, a deeper, undivided reality from which our explicit everyday world unfolds. This is not just a theoretical frontier. It is driving real-world innovation. At Stanford, scientists are developing new terahertz scanners designed to view these quantum processes in the brain in real time. The Allen Institute, in partnership with Google, is exploring the possibility of creating quantum AI systems that could, in theory, achieve genuine consciousness. The clinical applications are profound. This new understanding could revolutionize how we treat neurological and psychiatric conditions. Perhaps Alzheimer's and depression are, at their root, disorders of quantum coherence in the brain. We are already seeing the development of new therapies, like targeted ultrasound, that aim to improve cognitive function by directly stimulating the quantum vibrations of microtubules. The quantum perspective even reframes our deepest existential questions about life and death. A fundamental principle of quantum mechanics is that information is never truly destroyed. If consciousness is a form of quantum information, what happens when the body dies? It's a speculative leap, but it opens the door to the idea that death may not be an end, but a transformation, a shift in the state of that quantum information, which returns to the larger cosmic field. Critics rightly point out that observing quantum effects still doesn't prove they cause consciousness, and the measurement problem, what exactly causes the quantum collapse, remains a subject of fierce debate. Is it decoherence from the environment, or is consciousness itself playing the primary role? What we are witnessing is a great convergence. Neuroscience, quantum physics, and information theory are no longer separate fields, but are merging to create a new, holistic understanding of the mind and its relationship to reality. This new picture reveals a consciousness that is far stranger and more wonderful than we could have imagined. The old boundaries between science and philosophy, between the observer and the observed, are beginning to dissolve. We are not just living in the universe, we are participants in a cosmic dance, co-creating reality with every conscious moment. Where does this leave the question of free will? Classical deterministic physics seem to leave no room for it. But the inherent randomness and probability at the heart of quantum mechanics provides a potential source. Our choices may not be predetermined, but instead emerge from the collapse of quantum possibilities. This framework also offers a scientific basis for experiences of non-locality. In California, researchers are detecting quantum fields that extend beyond the physical body, finding synchronized signatures in people who are in close proximity. This could provide a physical explanation for phenomena like sensing someone's mood, or the uncanny experience of synchronicity that Carl Jung described, meaningful coincidences that seem to defy chance. These could be manifestations of non-local entanglement connecting our minds. The search is on to quantify these phenomena. At CERN, some are probing for theoretical particles of consciousness, playfully dubbed psychons. At IBM and Google, complex quantum computer models are being built to simulate quantum consciousness, and these systems are already beginning to exhibit surprising, creative, and non-algorithmic behaviors. This, however, brings us face to face with the other minds problem. If we create an artificial awareness, how would we ever truly know it's conscious? How can we detect the presence of an inner world that is, by its very nature, private? This line of inquiry leads us to a fascinating and ancient philosophical idea called panpsychism. Panpsychism is the view that consciousness isn't something that arises only in complex brains, but is a fundamental property of the universe, present in some rudimentary form in all matter, like mass or electric charge. In this view, a rock or an electron doesn't have complex thoughts, but it may have a flicker of simple, raw experience. Our complex human brain, then, doesn't create consciousness from scratch, but acts more like an antenna, focusing and amplifying this universal field of awareness. This resonates with the experiences of meditators, who often report that deep states of meditation boost a sense of coherence and oneness, as if they are tuning in to these cosmic frequencies. Similarly, psychedelic experiences often involve a profound dissolution of the ego and a feeling of unity with the universe, which could be interpreted as a temporary increase in this quantum coherence. Ultimately, this quantum view of consciousness doesn't provide easy answers to life's profound questions about death, purpose, or the feeling of being alone. But it does offer a new and empowering framework for exploring them. It suggests that the boundaries we perceive, between ourselves and others, between mind and matter, between science and spirituality, are not as solid as they appear. If we are all notes in a cosmic symphony, contributing to the music of the universe, then our lives, our choices, and our awareness have a significance that echoes through the fabric of reality itself. Take a moment to simply appreciate the mystery of your own awareness. Right here, right now, a collection of stardust, matter, has organized itself in such a way that it can reflect upon itself and the universe from which it came. This revolution in science is transforming our view of the mind and the cosmos, showing us that the questions we ask are just as remarkable as the answers we seek. Let's go one level deeper into the measurement problem. For nearly a century, physicists have asked, what causes the fuzzy quantum superposition of possibilities to collapse into one definite reality? The orthodox view is that any interaction with a measuring device does the trick. But what is the measuring device if not another collection of quantum particles? A more radical interpretation suggests that it is consciousness itself that solves the measurement problem. In this view, the brain doesn't just observe reality. Its active observation is what collapses the wave function of neural states, turning quantum possibilities into concrete, subjective experiences. This participatory role extends to how we perceive and remember our world. Perception is not a passive reception of data, but an active co-creation. Your brain is constantly selecting from a sea of quantum possibilities to construct the reality you experience. This could also explain the strange malleability of memory. When you recall a past event, you may not be accessing a fixed recording. Instead, you could be collapsing a superposition of potential memories, effectively recreating the past anew in the present moment. Your memory isn't a file in a cabinet, it's a quantum state waiting to be rendered. This culminates in the breathtaking vision of the physicist John Archibald Wheeler, who proposed that we live in a participatory universe. He coined the phrase "it from bit," suggesting that information is the most fundamental ingredient of reality. The it, every particle, every field, every object, derives its very existence from the bits, the yes or no answers generated by acts of observation or measurement. In this view, it is consciousness that actualizes reality from the raw potential of quantum information. Life, and especially conscious life, operating at the delicate edge of chaos, becomes the universe's way of navigating the infinite ocean of possibility and bringing forth actuality. Our consciousness acts like a spotlight, illuminating a tiny fraction of the infinite possibilities available at any given moment through these limited collapses. Yet the unity of our experience is maintained through the vast, entangled superpositions that connect everything, blurring the lines between the subjective and the objective, between the I and the universe. Your individual awareness is both a distinct point of view and an inseparable part of the whole. If our awareness influences quantum collapse, could our intention sway the outcome? Studies in California are exploring this very question, and early results suggest that focused intention can indeed subtly influence the probability of quantum events. This is the scientific frontier of agency. The idea that our thoughts are not just passive reflections of the world, but can actively shape our reality. On a collective scale, this implies that the shared consciousness of humanity is co-creating the world we all experience, one observation, one choice, one thought at a time. This idea finds a fascinating, if controversial, expression in the Global Consciousness Project, which has collected data for decades, suggesting that moments of widespread, focused human attention during major world events, for example, correlate with statistically significant ordering effects in random number generators around the globe. Is this evidence of a global mind at work? What are the limits of this non-local awareness? Does it transcend not only space but also time? This framework forces us to re-examine phenomena like remote viewing and precognition, not as supernatural fantasies, but as potential, if not yet understood, properties of a non-local, participatory consciousness. From this vantage point, the universe begins to look less like a great machine and more like a great thought or a collective dream. Reality is not a fixed, solid thing, but a fluid and responsive medium. Consciousness is the creative force that gives it shape. This perspective unlocks a sense of human potential that is truly vast. We are not merely puppets of deterministic laws, but active participants in the ongoing creation of the cosmos. We have traveled from the quiet hum of your own mind to the farthest reaches of quantum cosmology. We've explored the idea that consciousness is not an accident of evolution, but is fundamental to the universe, deeply connected through the mysteries of quantum mechanics, and an active force in the creation of reality itself. This is a profound transformation in our understanding of ourselves and our place in the cosmos. The mystery remains the key. The fact that you are here, now, aware and wondering, is the most profound fact of all. Your awareness is the universe knowing itself, the cosmos creating itself. And in that grandeur, I hope you can sleep well. What are your thoughts on this intersection of science and spirituality? Have you ever had an experience of synchronicity or deep interconnectedness that this perspective might help explain? I'd love to read your stories and reflections in the comments below. Thank you for joining me on this journey tonight. I wish you peaceful rest and wondrous dreams. And if you enjoyed our exploration, please remember to like this video, subscribe to the channel, and share it with anyone who might find a little peace in pondering the quantum symphony.